Now let's give a few quick integrating factor method thingamajingies. We'll start with this one here, the partial derivative of u with respect to y plus 1 over y, u equals y. Now as usual, we're not divided by 0, y cannot equal 0, and u is a function of x and y, which explains why we're using partial derivatives here. The integrating factor for an ordinary differential equation is given here. In this instance, the integrating factor method p of y equals the exponential 1 over y dy, which equals y. Now we use the integrating factor method for the partial differential equation, and it will give here this. Now dy by u and y equals y squared. So we're integrating with respect to t. Y we get yu equals 1/3 y cubed plus g of x. Hence the general solution is this by using the integrating factor method. And likewise we'll do it again with pretty much the same thing but with x's here. So our function is in terms of x and y. So multiplying both sides by the integrating factor method, 1 over x gives this here, which again is written in this form, and integrating with respect to x, and hence we get this here as our solution as a function of y. But well, we're multiplying by x here, so should be u. And so now we'll give another example here. Du by dx minus 1 over y, u equals 1. Y does not equal 0, and as always u is a function of x and y. Now our integrating factor method this time is 1 over y, but we're integrating with respect to x, so we can pull the 1 over y out, because when we're differentiating with integrating with respect to x, y is effectively a constant, so that can be pulled out here, and we get after integrating we get this as in the exponential form here, which then we multiply through the original equation, this one, so you get this, and integrating with respect to x, because we want to get rid of this, will give us this and this. Then multiplying by e to the x over y, just to clear it up a little bit, it gives us the final general solution here. And don't forget, these are not constants like they would be in ordinary differential equations, because these are partial differential equations. So we get a function of y here. Like if you don't already know this, if you're integrating with respect to one variable, like integrating x squared dx, it would give and then we would have plus c. But in this case we have x's and y's, so we don't have a constant of integration, we have a function of integration, and the function is here of y, because don't forget the function up here to begin with was u of x and y, so that's why we have a function of y as our function of integration. I'm sure you probably already know that anyway, but please do like and subscribe, and thanks for watching.